Well, hello C++ programmers and fellow game developers. Brian Malloy here, and today I'd like to talk about Painter's algorithm, which you see displayed right here before you on a wiki page. And this wiki page kind of describes how it works, and you can read this at your leisure if you like, but the idea is that things further away, like take these trees, things further away look smaller than things closer. So what you can see is that here we have smaller trees and we draw those first, and then here we have larger trees, and it gives a feeling of depth. And actually Painter's algorithm just by itself, you can see here, gives this feeling of depth, although there is some tessellation and other things going on here, but nevertheless you get the idea that we may have a little bit of depth here. So one thing you can do is combine, let me just show you what I'm up to here. We can combine another technique called parallax scrolling with Painter's, and I hope you can see all this, and I'm just going to come down here and we'll see, you'll see, hopefully we'll get to some meteors pretty soon, and you'll get what I'm talking about with Painter. There you go. So okay, so you see Painter's algorithm. Take a look. What you might see here, I hope, is me getting blown up, but if you look, the smaller meteors are drawn in the background. You see them there? I'm going to put God mode on so I don't have to pay attention to whether I'm getting killed. So if you look back here, like there's a smaller one. It falls in back of the mountains. This is a bigger one, falls in front, and that one can kill me. And then these medium, well, let me see if I can show you a medium. Let me move to a medium one that falls. There's one that's going to fall in the middle. The medium-sized ones fall in the middle. So the idea is that you can create an illusion of depth, especially when you combine it with parallax scrolling. So what you see here is a combination of parallax scrolling together with Painter's algorithm to provide that illusion of depth, because 2D video games have a lot of advantages actually over 3D because they're more efficient, you can get a lot more stuff done, and they're cute with this illusion. And so how do we do this? Well, I think it works pretty well here. Let me show you another example. Here are some crows, and if you take a look at these guys, it's the same idea. Let me tab around. So the idea is that the smaller ones are drawn first and the larger ones are drawn last. Let me skip around like to maybe some that are more that demonstrate. Oh, I just rotated them. I hit the wrong key. Here we go. See how the smaller ones are drawn in back of the larger ones. And so the idea is that you feel like the bigger ones are closer and the smaller ones are farther away. They're actually it's all 2D, so there's no such thing as depth. But you get that feeling of depth. And that's the idea. And by the way, we are combining this once again with parallax scrolling, and I think that helps. This is an example I got from actually a game book that I got the code for. But the game book did not use Painter's algorithm. It did use parallax scrolling, but I've added the Painter's algorithm to give even more feeling of depth than you might get from just the parallax scrolling alone. Let me show you some examples where it works even less so. So here's an example of, here we have no parallax scrolling and not even a background to give the illusion of depth, but I have painted the coins. But you still don't get much of a little bit, but you don't get much of a feeling of depth. If you can see, the smaller coins are drawn in back of the larger ones. You can see that. The bigger ones are drawn, so we're drawing them small to large. And you do get, nevertheless, the feeling of depth, but not as well as you did when you combine it with the parallax scrolling. And here's the other extreme. So here we have, honestly, I think parallax gives you nothing here because there's no texture to these orbs. These orbs are just really circles, frankly, with no shading to speak of, and you get no feeling of depth, even though we are still drawing the small ones first and the larger ones. So what I've tried to do is take you through a progression here of where I think it looks pretty good to where I think it doesn't look quite so good. And the idea is for you to bring that about. Now, if we look at the code for this, it's pretty easy. You know, it's going to be the same no matter what API you're using. Oh, I lost it. Let me see if I can bring it back. If I can just pull this down a little bit. What I do here is I have a little loop. Let me see if I can find it. My update loop. See, let me go to my draw loop. Okay, there. Let me go. Where's draw? Here's my draw loop. And what I do is I draw the clouds first because that's my farthest background, the one farthest most or whatever. Then I draw the smaller of the group of 3 meteors. And then I draw the mountains, then I draw the medium-sized meteors, then I draw the hills, and then I draw the large meteors. And then I guess I'm drawing the explosions, and then I draw the 2 Peters. So the idea there is that I'm just trying to show you how in this example, if we get to the meteors, you'll see that the way I do that is I draw the clouds back here first. They're going to get me, aren't they? Maybe just put F5 on. Don't get me. Okay. So I draw the clouds here first. Then and then I draw the smaller meteors. Let me show you the smaller meteors. Then I draw the small meteors. Then I draw the mountains. Then I draw the medium meteors. There's one. And then I draw the hills. And then I draw the large meteors. And I draw Peter. And then there's the baby. Okay, so that's the idea. That's the idea with Painter's algorithm, and it takes a little bit of artistic appreciation, and a bit of an eye. Not that I've got one. I lucked into this, believe me, but that's the idea with Painter's algorithm. You can really add this feeling, the illusion of depth. Hey, happy programming. Brian Malloy, over and out.